Okay, guys, so today we're going to make a quick example in Math 3D for motion in space. It's going to take us just a second. So the first thing I'm going to do is I'm going to start with an example parametric curve. So this is going to be my position curve. And I'm just going to use this default one because I like it. So this parametric curve, I'm going to change the name to position. So this is my position curve. What I mean by that, so I'm going to add some stuff here. I'm going to add a point and I'm going to add a vector. These are all going to be position things. So they're all going to be blue. I also need a variable slider. And I'm actually just going to call this folder position stuff. Okay, so we've got our position curve. That's a vector valued function, right? So categorically that takes a number t and turns it into a vector, capital P, maybe with a hat on it, right? This point here is going to be me thinking about what point am I at for a time capital T down here. So that capital T is going to be a specific version of kind of the little t up here. So I'm just going to actually copy this thing. So into my point, I'm going to put cosine of capital T. I'm going to put sine of capital T, and I'm going to put a capital T. So see how that point jumped from the origin out onto this curve? So now if I run my variable slider, right, I'll see that point go kind of wrap around my position curve. You can see it making its way through there, right? I'm going to send it from minus 2 pi to 2 pi, so it covers the same thing here. I'm getting those values out of the t's in my position curve, right? So I've got my point, that is the position, right, in space. And this vector here is going to actually be the position vector. And this is, one of those things, right? We're going to just take our point, think about it as a vector from the origin. So now when I run this, I should see all these little position vectors that point out at that point, and that point is a point on my position curve. So these are kind of three slightly different ways of saying the same thing. So now that I've got my position stuff covered, next I'm going to add the velocity, right? So first things first, I'm going to add to this a vector, right? And this vector is going to be my velocity. So I'm going to turn my velocity vector red. Okay, so now I need to know how to differentiate. So when I'm differentiating a position curve, right, up here, I'm looking at this position curve here, and I'm just going to differentiate all of that. Now I'm actually going to stuff that into a vector. So I'm going to use the kind of capital T variable here, but realize that I'm just making this vector at a specific time instead of making all of them at once. So the specific vector that I'm going to make, right, is going to look like the derivative of cosine. So that's going to be minus sine. And again, I'm putting in a capital T, but that's because I'm trying to draw one at a time, not trying to draw all of them. Then in my y coordinate, I've got the derivative of sine, so that's cosine. And again, we're putting in a capital T because I want one of them. And the derivative of t is 1. And doesn't matter what variable I'm plugging in. So you can see that red vector kind of goes in a circle, right? It actually is tracing out a circle in three-dimensional space. We could see what that position curve looked like, or the velocity curve looked like if we wanted to, but it's not super relevant here. See that it's always pointed up 1 unit though. So I want to put that red vector out on this blue point so it actually looks a little better. So what I'm going to do here, and I should add another folder. So I'm going to add a folder here. This red vector is the velocity, right? That's the rate of change of position. This folder is going to be the velocity folder, right? And so I've got my velocity vector. I just need to tail it. So I'm going to tail it to the position vector, right? So I'm just attaching it to that position point. So now you can see that my red vector, my velocity vector, is now showing you how it's acting on that curve. And you can see that red vector is actually tangent to that blue curve, which shouldn't be a huge surprise. That was my kind of goal, right? Okay, so there's one more I should be able to get. That's an acceleration vector. So I'm going to go here and I'm going to throw another vector in. Oops, I should probably throw another folder in. So this vector is going to be in the acceleration folder. And this guy here was actually velocity as a vector, right? So that's my red vector. Now my blue one, I'm going to call, or my vector here that I just made, my acceleration vector, I'm going to call that orange. Okay, so that orange vector better be the second derivative, so I need to differentiate this function. So if I differentiate the acceleration function, or the velocity function, I'll get the acceleration function. So I need the derivative of minus sign is cosine. I'm going to evaluate it at capital T again, because I'm trying to get it at the one point I'm talking about. When I differentiate sine, I get when I differentiate cosine, I get minus sine. Again, got a capital T there. And when I differentiate 1, I get 0. So you can see that orange vector is now kind of spinning around. I really want that to be out on the end of my red vector so you can see how this works. So that's going to be tough. I need to tail this, and the place I need to tail it to is going to be the position vector. And so we'll plug in our position. So now we've got it tailed up there. That's how we're kind of accelerating. But acceleration isn't a change in position, it's a change in velocity. So I think I should put it on the end of the red vector. And I think we can just go ahead and do that. And there we are. Beautiful. So you can see that the orange vector is how the orange vector is pulling on the red vector, and the red vector is pulling on the blue vector, and that's describing how this point moves through space. Hope this makes sense, guys. This thing is so freaking cool. This is this is where Calc 3 becomes rocket science. Like, when people talk about doing rocket science, they're talking about doing a bunch of physics, they're talking about doing a bunch of chemistry, they're talking about doing a bunch of hella hard engineering. But the really, really cool stuff is all the physics boils down to this piece of kinematics, basically. So this is very, very applicable. You see this happen in your life, right? When you're driving down the road, you're turning the steering wheel and tapping the brakes. Tapping the brakes is applying an acceleration vector. Turning the steering wheel is also applying an acceleration vector, right? We're kind of constantly fiddling with those things, and fiddling with those things changes the way we move through space. I encourage you to sit around and see if you can see these in the world. Anytime you see something moving, you should be able to attach these little blue, red, and orange vectors to it. See if you can get some enlightenment out of that. It's actually a really fun thing to do. Thanks for watching, guys.